So this is the third video on Web3 and blockchain subject. Here we are going to continue our work on monitoring the transactions over the network or the blockchain, and then we will see how we can find transactions that we have the characteristics that we want for later using them to make some profit. So in this video we will see how to find a transaction that's for a specific token, or how to see which tokens are being bought with high volume over the network. We start the code by importing Web3 as always. And here we also need two other libraries. The first one is abi-decoder, and the second one is colors. As we write the code, I will say what each of these libraries will do for us. But before using them, we need to install these libraries with the npm install command. Like before, we define our main function as an asynchronous function, and this is because we will be communicating with the network with an unknown delay for executing our commands. So to make it easy for us to follow the execution of the program, we log all the states. First we log connecting. This dot yellow here means that we want the text to be printed into the console with the color of yellow, and this is why we imported the colors library after. Since we are going to be monitoring the network and the ongoing transactions, again we are going to use the WebSocket connections for our Web3 instance. So we will write this code as web3.providers.websocket-providers. And for the WebSocket provider, like before, the Quick Note website is a website that provides good service. It provides us with 10 million free requests, which would be more than enough at least for a couple of tests. And now we define the subscription object as the Web3 subscription to pending transactions events. Here we can subscribe to many different events, but the one that's interesting for us is pending transaction. After doing the subscription, we log to the console again and we print the good news. We are connected and we are going to be waiting for the transactions to arrive. For this one, I choose the color of green. Now that we are subscribed, we'll wait for the events. The event in this case is called data. And in response to that, we are going to define an asynchronous function again, which will get the transaction hash as the input, and then we will do our process inside this function. So this transaction hash that we receive is like an IP or like a postal code, and it will just point to a specific transaction. But to get more details of that transaction, we will need to run the web3.eth.getTransaction function and pass this transaction hash as the input. So just out of experience, there will be situations where we will get problems when reading transaction data, or we will get nothing in return. and in this case we want to disregard this transaction. So with this condition we will return, which means we are not going to do anything, and we will go back to the await function and wait for the new transactions. This error will happen more often in cases where you have the subscription to one provider and you have the get transaction called on another provider. But here, since we're using the same provider for both, it's rarely going to happen. And again, here we need to add await. This keyword means that the function that's going to run needs some time, so we'll wait for this before going to the next line. The other field that we want to check is the to field. So sometimes this one is also null, and in that case we want to return. We don't want to continue with this transaction. Now we also experienced some problems with the transactions that we detected already, and these were transactions that were waiting for being mined for a long time. And the reason was that either the gas amount was not enough or the gas price was not enough. So we add another condition here to reject these kinds of transactions. So the smallest amount of gas for a transaction on Ethereum network is 21,000. And if someone sends a transaction with less than this amount of gas, it's going to be rejected or waiting for being mined for the infinity. So we want to reject these ones. And also, for the moment, or at the time that I was writing this code, the gas price of the network was 9 GUI. And each GUI is 1 giga away. So a 9 with 6 zeros here. So our target this time are transactions which are buying a token using Ethereum. And we don't want to capture all of them. We only want the ones that have a certain amount of value. And by buying a token, we mean the swap function of Uniswap. So we write this condition, and if the transaction value is less than 1 with 15 zeros in front of it, which means 1,000th of 1 Ethereum, $1 or $2 right now, we are going to reject this transaction. We can always change it and make it a bigger value. And we also want our transactions to point to the Uniswap router. So we check if transaction to field dot to lowercase. That is because we turn all the addresses to lowercase letters before comparing them. And here we put the address of the Uniswap router. To find the address of this Uniswap router, we go to Google and we search for Uniswap v2 router. In this video I was using v2 router because at that time v3 was new and v2 was well known for being functional since long time and everybody was using it. So we take this address and just pay attention to take the router 02 because there's already a router 01 which had bugs and was stopped. So this is the good address. And we also use the to lowercase method again. So now if a transaction has passed all these conditions, it means that we have good information about it. It is willing to pay enough fee to be mined, and it has enough value and is painting to the Uniswap router. Now we are going to get more details about the data that's included in that transaction. So the transactions that are interacting with a smart contract, like the ones that we are looking right now, the swap transactions that are pointing to Uniswap router, which is a smart contract, do have a field which contains the data. So when we are calling a smart contract, we pass some data to do some process. And this input or data field is of interest for us, and we want to study that and decode it. And this is why we use the abi-decoder library, because it can decode this data for us. The ABI itself is like a dictionary or a map which maps each input or each hex data to a method or a property or a parameter of a smart contract. So each contract has its own ABI. So in general, big and famous smart contracts and also most of the tokens, they have public contracts. So you can easily see their code, the code of the smart contract that's running on the blockchain. This is because they want to gain trust, and the developers and users want to be sure that these smart contracts do not have loopholes or do not have functions that can steal some money or can be unfair in some transactions. And in consequence, we have the API of the smart contract of Uniswap router, which is publicly available. We just need to go to etherscan.io, look up the address of this contract, and go to the contract page. So in this page, you see the original source of this contract, the Solidity program, and then if you scroll down a bit, you will see the contract API. You can directly copy it in your memory and then go back and paste it in our code. Since this API code is very long, I'm going to open another .js file, and here I define constant Uniswap equals this code. And in the end, we need to export it as a constant and then import it in our main program. So module.exports equals a set of functions or variables, which in our case is only Uniswap API. So this is not a necessary step. We can directly paste it in our main program, but I just wanted to be cleaner regarding writing the codes. So to import this constant value in our main program, we write var Uniswap API equals require this JavaScript file, and this file is in the same folder as our main program, which is called codes. So I write it like this, and in the command prompt where we are going to run the code, we need to go to the codes folder. Okay, so now we have a set of Uniswap, which is imported from this 9_API.js file. Now inside our code, we write var data as equal to API decoder, calling decode method, and as the input, we pass the transaction input field. So again, to avoid errors, we return if the data that we get is null. But if it's good data, we want to print it into the console and see what we get. So what I forgot to tell you is that you need to add this API of Uniswap to the API decoder library before using it. And now we can call our main function. Okay, I made this mistake again. We need to subscribe to pending transactions with the S in the end. And now we'll keep waiting for a good transaction to arrive. Okay, we got a couple of transactions. Let's stop the code and see what we've got. So this first one is the first transaction that we captured. Among the parameters that we get from the abi-decoder, the one important one is this name, which is swap exact if for tokens. This is the method inside the smart contract that's being called. And the next important one here is the path, which is an array of addresses, and it starts by the token that you're paying and ends with the token that you want to receive. Two is the wallet address to which we want to send the tokens, and the deadline is the deadline for executing this transaction. Here we are interested in knowing which token is being bought, and this data is not inside the first but inside the second element, which is the path, and it will be the last element of the value array. So now instead of logging the data itself to the console, we choose the key param, which is the parameters, and then inside this one we don't want the 0, we want the element number 1 or the second one, and then inside this element we want the key value. Now this will give us the array of the addresses, of which the last element is going to be the address of that token. Okay, I just needed to add ticks around value, and yes, here you see we got an array of addresses. So now if we check these addresses, the first one is wrapped ETH, which is Ethereum that is being tokenized to be able to interact with the transactions and smart contracts. And the second one is USDT, which is dollars. So in short, it's paying Ethereum and it's getting dollars instead. This is what this transaction is doing. So now instead of printing it out, we define a parameter path, which is equal to this array of addresses, and then as the token address, we will get the last element. And that will be the element which is equal to path.length, which is the number of elements minus 1. So let's print out to the console and see what we get. We could directly put 1 instead of path.length minus 1, because if we have 2 elements, 1 will point to the second element. But the thing is that in some specific ways, when we run a smart contract in Uniswap, we are going to send a chain of addresses. So we send token A, then we get token B, then token B is turned into token C, and so on until the last element. Let's find a transaction like this so you can understand better what I'm talking about. Okay, maybe it's better if I look to the Uniswap V2 router transactions directly. So let's check a transaction here. You see this one. No, it has only 2 addresses, but okay. So the first one is a token that's being paid, and the second one is a token that's being returned to the address. And the thing is that sometimes you have inefficiencies in the market prices, and if you pay token A, you get token B, and then you change token B for token C, you will get more of token C compared to the situation where you pay token A and directly turn it into token C. This is called arbitrage, and there are many robots out there looking for these kinds of chances to profit. Okay, let's go back to our code. So now we have the address of the token that's being transacted, and we want to get the name of the token. To get the name of that token, we need to communicate with its smart contract. So for example, if we check this token address that we found, we will see that it has a public smart contract again, so we can check its contract code. We can scroll down, see all the other Solidity codes that being run for the smart contract. And further down we will see the API. And since we are going to be communicating with this smart contract, we will need its API, so let's copy it. Now let's go back to the API.js file. So I've already added this token. I will remove it and show you from the beginning. We define another constant called token API and we paste the code that we copied into clipboard. And now we want to export Uniswap plus this token API that we get now. And here on the other side, we want to import token API from the require function. So before writing the code, let's go back to etherscan.io website. This is a powerful website. Here you can see the information, but also you will be able to communicate with the contract directly through the website. And here you see we have read contract and write contract. Read is for the commands which do not change any state. It's only for reading the values of parameters on the blockchain. And write is for commands that modify the state or value of a variable over the blockchain network. And here you see on the read contract page that we have several values that we can read. The one that we want to see is the symbol. We can also check the name, but let's go for the symbol right now. So to access this method and call it and get the name of this or the symbol of this token, we need to define the token symbol. Before that, we need to define the token contract. So here we define token contract as, so this is not communicating with the network, so we don't need a wait. We just define it as a new web3.eth.contract, and as the input we send the token API and the token address. So now we can call the symbol method and get back the symbol of this token in return. And since here we are communicating with the network, we need to use the keyword await. And this is the way that you can call a method in a smart contract in Web3. It doesn't matter if you are going to read a parameter or a variable inside the smart contract or call a method. It's always like the token contract dot method and dot what you want to read, with a dot call in the end. And we also need to put the parentheses after the symbol. So now we can run and wait for this code to find the transaction or to find the token that is being bought over the network. Okay, so we have two transactions with the Shiba token. If we let it run, it will continue to find transactions and notify us with the token's name. So here I've modified the way we are logging to the console, and we print the name of the token and the equivalent Ethereum value of the transaction. So just like this, you will be able to see which tokens are really being bought and being traded over the network, and you can use this information to make some profit. Maybe you can use it as a buy signal, or you can share this information and send a notification to the users of your website or web service of a token which is being traded heavily over the blockchain. That's it. This video is finished. I will continue this trend over the Web3 and blockchain in the coming videos.